expert wire respooler and resourceful problem solver. Successfully salvaged and respooled 2 full but broken spools of number 12 stranded THHN, saving them from potential waste. Meticulously unwound and rewound 500 feet of wire by hand, maintaining meticulous organization to prevent tangling. Demonstrated exceptional patience, attention to detail, and a determination to find innovative solutions to challenges. Skills include wire respooling, electrical repair, resourcefulness, detail-oriented, and problem-solving. Additional qualifications include a proven ability to work independently and complete tasks efficiently, a strong mechanical aptitude and proficiency in handling tools, commitment to minimizing waste and maximizing resource utilization. When working with electrical wire, understanding the properties of the wire itself is essential. Number 12 THHN stranded wire is a common type used in residential and commercial electrical installations. The number 12 refers to the American wire gauge, or AUG, which is a standardized system for denoting wire sizes. A smaller number indicates a larger wire diameter, and thus a greater current carrying capacity. THHN stands for thermoplastic high heat resistant nylon coated. This indicates the insulation material and its properties. Thermoplastic insulation softens when heated, allowing the wire to be bent and shaped during installation. High heat resistant means the insulation can withstand higher temperatures without degrading, typically up to 90 degrees Celsius or 194 degrees Fahrenheit in dry locations. The nylon coating provides additional protection against abrasion and chemicals. The stranded designation means the wire is composed of multiple thin strands of copper twisted together rather than a single solid conductor. Stranded wire is more flexible and easier to work with, especially in tight spaces or when making bends. When respooling wire, it is important to maintain the integrity of the insulation. Nicks or cuts in the insulation can create weak points that may lead to electrical shorts or other hazards. Careful handling during the respooling process is crucial to prevent damage. Before beginning any electrical work, it's important to understand local electrical codes and regulations. The National Electrical Code, or NEC, provides guidelines for safe electrical installations. These codes specify the proper wire sizes, conduit types, and other requirements for different applications. For example, NEC Table 310.15b16, formerly NEC Table 310.16, specifies the allowable ampacities of insulated conductors rated up to and including 2000 volts. For number 12 AWG copper wire with THHN insulation, the ampacity is typically 30 amps when used in a circuit with no more than 3 current carrying conductors and a raceway cable or direct buried. However, local codes may have more restrictive requirements, so it's always best to consult the local electrical inspector. When working with electrical wire, safety is paramount. Always disconnect the power before working on any electrical circuits. Use insulated tools to prevent electric shock. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, it's best to hire a qualified electrician. Electricity can be dangerous if not handled properly. Understanding wire properties and applying appropriate electrical codes is vital for safety. Proper respooling can prevent waste and save money. When handling electrical wire, make sure to properly dispose of any scraps or damaged wire. Copper is a valuable resource that can be recycled. Contact your local recycling center for information on how to recycle copper wire. Resourcefulness in electrical work extends beyond just respooling wire. It also involves finding creative solutions to problems such as reusing existing materials whenever possible or finding alternative methods to accomplish a task. For example, if you need to run a new circuit but don't have enough space in your existing conduit, you might be able to use a smaller diameter wire or a different type of conduit to make it fit. However, it's important to ensure that any modifications comply with local electrical codes and regulations. Attention to detail is also crucial in electrical work. Even small mistakes can have serious consequences. For example, If you don't properly tighten a wire connection, it could cause a loose connection, which can lead to overheating and potentially a fire. It's important to double-check all your work and ensure that everything is properly installed and connected. Problem solving is an essential skill for any electrician. Electrical systems can be complex and troubleshooting problems can be challenging. It requires a thorough understanding of electrical theory and the ability to diagnose problems systematically. For example, if a circuit breaker keeps tripping, you need to determine the cause of the overload. This could be due to too many appliances on the circuit, a short circuit, or a ground fault. By using a multimeter and other test equipment, you can identify the source of the problem and take appropriate corrective action. Strong mechanical aptitude is also important for electrical work. Electricians often need to use a variety of hand tools and power tools to install and repair electrical systems. It's important to be proficient in using these tools safely and effectively. For example, you need to be able to properly strip wire, make connections, and install conduit. Commitment to minimizing waste and maximizing resource utilization is becoming increasingly important in the electrical industry. With growing concerns about environmental sustainability, electricians are looking for ways to reduce their impact on the planet. This includes recycling materials, using energy-efficient products, and designing systems that minimize energy consumption. For example, when installing lighting, you can use LED fixtures, which use significantly less energy than traditional incandescent or fluorescent lights. You can also install occupancy sensors to automatically turn off lights when a room is unoccupied. It's beneficial to also know the different types of wire and their uses. THHN wire is suitable for dry locations and can be used in conduit or other raceways. THWN wire is similar to THHN, but is also suitable for wet locations. UF wire, or underground feeder wire, is designed for direct burial in the ground. Understanding the different types of wire and their applications is essential for selecting the appropriate wire for a given project. Wire connectors are also important components of electrical systems. Wire connectors are used to join two or more wires together. There are different types of wire connectors, such as wire nuts, crimp connectors, and push-in connectors. It's important to use the correct type of connector for the application and to ensure that the connections are properly made. Improperly made connections can cause overheating and potentially a fire. Electrical boxes are used to enclose wire connections and protect them from damage. There are different types of electrical boxes, such as metal boxes, plastic boxes, and weatherproof boxes. The type of box you use will depend on the location and the application. For example, if you are installing an outlet outdoors, you will need to use a weatherproof box to protect the connections from the elements. Conduit is used to protect wires from physical damage. There are different types of conduit, such as metal conduit, PVC conduit, and flexible conduit. The type of conduit you use will depend on the location and the application. For example, if you are running wires underground, you will need to use PVC conduit, which is resistant to corrosion. Circuit breakers are used to protect electrical circuits from overloads and short circuits. When a circuit breaker trips, it interrupts the flow of electricity to the circuit. This prevents damage to the wiring and appliances. It's important to use the correct size circuit breaker for the circuit. Using a circuit breaker that is too large can allow the circuit to become overloaded, which can cause a fire. Ground fault circuit interrupters, or GFCIs, are used to protect people from electric shock. GFCIs are designed to detect ground faults, which occur when electricity flows through an unintended path, such as through a person's body. When a GFCI detects a ground fault, it immediately interrupts the flow of electricity, preventing serious injury. GFCIs are required in areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor areas. Electrical testing equipment is used to diagnose problems with electrical systems. Multimeters are used to measure voltage, current, and resistance. Wire tracers are used to locate wires behind walls or in conduit. Circuit testers are used to verify that circuits are properly wired. Understanding how to use electrical testing equipment is essential for troubleshooting electrical problems. In residential wiring, common circuits include 15 amp circuits for lighting and small appliances, 20 amp circuits for kitchen appliances and laundry equipment, and 30 amp or larger circuits for electric ranges, dryers, and air conditioners. The size of the circuit breaker and the wire gauge must be appropriate for the load. For example, a 15 amp circuit typically uses number 14 AWG wire, while a 20 amp circuit typically uses number 12 AWG wire. In commercial wiring, circuits may be larger and more complex depending on the building's electrical needs. Commercial buildings often have three-phase power systems which provide more power than single-phase systems. Three-phase power is used to power large equipment such as motors, HVAC systems, and industrial machinery. The voltage levels in commercial buildings may also be higher than in residential buildings. Common voltage levels include 208 volts, 277 volts, and 480 volts. Electrical blueprints are used to plan and document electrical installations. Blueprints show the location of electrical equipment, such as outlets, switches, lights, and panels. They also show the wiring routes and the types of wiring used. Understanding how to read electrical blueprints is essential for electricians. Continuing education is important for electricians to stay up to date on the latest electrical codes and technologies. The electrical industry is constantly evolving, with new products and techniques being developed all the time. By taking continuing education courses, electricians can learn about these new developments and improve their skills. This can help them provide better service to their customers and ensure that their work is safe and compliant with current regulations. The successful respooling of the wire demonstrates the ability to work independently. Completing tasks efficiently is crucial in various contexts, ensuring timely project completion and optimal resource utilization. Strong mechanical aptitude demonstrated through the respooling process showcases proficiency in handling tools and equipment essential for various tasks and projects. A commitment to minimizing waste and maximizing resource utilization is a valuable trait, reflecting environmental consciousness and efficient resource management practices. By respooling the wire, a practical approach to resource conservation is exhibited, preventing the disposal of usable material.